All right. How is everybody doing today? How was your Thanksgiving? How many of y'all said you would be here on Wednesday and weren't? Come on, there were a whole bunch of people raise their hands. Have you all watched the video from last Wednesday? The answer is not everybody, apparently. So, okay. Can I turn it down just a little? Is that okay? All right. So Project 5 is posted. The first part of the autograder is posted, and the second part of the autograder will be posted tomorrow. So I spent most of my Thanksgiving break working on the autograder for you all. Anyway, it's an experiment. I'm mostly doing it for myself to see if it's worth using in this class. And my answer is, I don't know. What do y'all think? Do you like the autograder? You do, more than just turning in code and hoping for a good grade? Okay. I'm not sure I expected that. Any questions about leftovers from Project 4, or if you've looked at Project 5 about Project 5? Yes, sir. Yeah. You got an 85 on Project 5 because 15 points is graded by hand. Uh-huh. Oh, okay. Okay. Yeah, my autograder is not as thorough as it should be for that project. So, but I'm happy to take points away from you. So, yeah. You have to use the overload operator. Sorry, we are overloading the operators in this one for both the base object and the subject object. Okay, so what you'll have to do is you'll have to read all the subjects, then read all the babies and associate the babies with the subjects. Kind of like we did last time, right? It's a similar idea. Last time we read all the subjects and then we associated them with their symptoms. This time you will read all the subjects and then associate them with the baby. The reading should be done with the overloaded input operator. You also have to overload the output operator. Even though you don't actually use that in your test, I test for it in the autograder. So, and report can use it, the report method, which I also use. Yes, sir. In one of the, that might just be an error. Let me just take a quick look. This one? No, that's absolutely necessary. And the reason is because when we're doing input, we are doing input into an object, and we want that data to persist, right? So that is that's a pass by reference instead of a pass by value, so that when you read things in using the operator, it will actually change the thing that it's reading into. So when we get back to where we called it from, it has the new data in it. Does that make sense? You can shake your head no. I look like I just broke your will to live with that answer, right? But here's the deal: we're reading stuff out of a data, we're putting it into a baby object. We want the stuff that was coming out of the file and in the baby object to remain in the baby object so we can use it, right? With me on that? You still look skeptical. Okay, you're with me on that? Okay. So the problem is that we're working in this friend function and we're putting the data into a baby object in the friend function, but we want that data that goes into that baby object to return and exist elsewhere in our program. Okay? We have two ways of getting data back. We can either use a return statement or we can use a reference parameter. This is a reference parameter. So you don't have to return it. In fact, the thing that's getting returned is one of these iStream objects, which is magic as far as we're still concerned. So, yep. Uh-huh. Yep. Okay, so the question was, for those of you watching on video, in project 4, we had 2 different constructors for the subject class. One took no parameters and just used some default initializations, and one took a particular set of parameters and would initialize things at once. What is best practice to use? And the answer is, it depends. In practice, you're probably going to have a default constructor. In this case, sometimes the compiler will build one for you. I was finding that some of the compilers I was working on weren't building that for me. Okay, so I put that one in there. In terms of, calling a constructor, a default constructor, and then calling all the setter methods to set everything inside, that's a pain in the ass. I thought it was easier just to have one that you could give everything as parameters. So I think what you're going to find as a matter of practice is that most do it more than one way. Okay, so some will have a default, some will have a default with a set of parameters, some might have other mixtures of things in between. So, and there's sometimes an example I do where, well, we won't talk about that, but we can talk. You can do a lot of different things depending on your situation. In the in the trial class, you absolutely can and should use the overloaded operator. Nope. Once you have made this overloaded operator part of the baby class, then down here for like load subject or load baby, you can literally just do file angle baby. Nope, not at all. Once you've made it for the baby class, in fact, you know what? I should actually update this to say that you should use that. Would you send me an email to remind me? And then I'll put that on there because it actually makes your life easier. Like once you've made the overloaded operators work, you can just use them, and then load subject and load baby are like 5 lines each, right? Open the file, wall file into baby or wall file angle subject. That's it. And you can just loop through. You don't have to like create a default thing and set a bunch of things. You just put everything in there all at once. That's why we do it. Yep. So the question is, are we going to have 2 lists, one with babies and one with mothers? Here is your list definition for the whole project right there. Subject, head, subject, points to the linked list of subjects. What's going to happen is we're going to have a linked list of subjects. Each subject will have a baby, and the baby is part of the subject. In fact, where is the definition of subject? Right here. Here is the baby that is part of the subject class. So it is not a linked list. It is a linked list of subject objects, and each subject object has a baby object inside. Just like if you had a linked list of things, you could have strings inside, right? A string is just an object like a baby is an object in this example. Babies are actually people. So I think everybody was once a baby, even if we don't remember it. All right, other questions? Going once, going twice. Okay. So last time we were here, we were working on some linked list examples with the node class. Do you all remember the node class? What does the node class have for its private data members? Data and a pointer to the next node, right? What is the difference between the node object and the subject object in the project? Pardon? So instead of data in the subject object, we have different things, right? In Node, all we have, and I'm not showing this right on the screen right now, but in Node, all we have is an int, right? So when we look at, if we look at what's inside a node, all we have is an int for data and a pointer, a node star, to the next node. The subject class will be identical to this, except instead of just having an int for data, we will have other stuff. We'll have a baby, we'll have a subject ID, and that, right? So everything we're doing and showing you this node example is exactly the same as it will be for the subject example. Okay? Exactly the same. It's just that these things, well, they're called different things because we're calling this a node instead of a subject, right? So there's different data inside, but they will all be linked together almost exactly the same way. Actually, exactly the same way. We just have different names for the variables. Yep. So here's what we're doing is think of it this way. We have a vector, right? And the vector says you have the little angle brackets and you can put one thing inside. And then the vector can hold all of those, okay? When we don't use the vector, we have to use pointers to keep track of where things are. And what we're doing is instead of having like an angle bracket with int or something, we're having like, my analogy is breaking down because it's Monday, but instead of having like a subject in the angle brackets, we will have a subject that has a pointer to the next subject. And that subject class has all the stuff it needs inside of it. And instead of putting them in a vector, which operates magically through pointers that we haven't seen, we are keeping track of everything manually ourselves. Does that answer your question? Uh-huh. Yep. Each specific node has two things in it. It's got, this one has a number and it has a pointer to the next node. When we get to the subject class, it will have different stuff in there. I don't remember off the top of my head. Yes, I do. The subject class only is cut way down to save you some typing, and the subject class only has two things inside of it. It has a subject ID, and it has the experimental category that they're in, either a character E or C. So to change this to the subject class, you would change int data to subject ID, unsigned int subject ID, character or code, and you, instead of having node star next node, you would have subject star next subject. That's it. But all the operations that I'm going to show you for linked list, traversing the linked list, and today we're going to talk about finding nodes and stuff like that, all of them will operate exactly the same way. And I hate to say this, so I won't. Okay. I reconsidered that. All right. But pretty much, you can use this node, the stuff we're doing in here, like as a huge template, as a huge example for what you need to do on Project 5. All right, almost all the functions and methods are super duper similar. All right. Everybody good on that? All right, so last time we were looking at, we had this node class, and then we created a linked list class. And this linked list class is going to be the thing that holds our list. Okay? Everybody good with that? So instead of trying to put the head of the list and keep it separately, we're building it into a class. When you get to the project, instead of a linked list class, you will have a trial class. And the trial class will do most of this stuff, okay? The trial class is where the head of the list is, right? So here we have node star head. This is part of the trial class. And if we look at the trial class here, instead of node star head, we have subject star head subject. Same thing, just with different data types. Okay? And if we look at what we have to do in here, in the subject thing, we have add subject, which means adding a subject to the list. And if you look at the code we've already written for the trial class, or the linked list class, we have add element. Do those two seem very similar? Yes, they are really similar, right? And if you look at what else you have to write, you have to write find subject by ID, and we haven't written that one yet. Okay, that's one of the things we'll work on today. So in our linked list class, we have a few things. We have a constructor for the linked list. The constructor does something incredibly important. What is the incredibly important thing the constructor does? It sets it to null. Yeah, do not underestimate the importance of setting pointers to null. Really. Like, it will save you all sorts of headaches. And in fact, working on the autograder for this, like, I have to be so careful that your code is not working with null pointers, because If you have a null pointer or a dangling pointer, then what will happen is the autograder will crash. So the autograder might crash on your code this time. I've done my best to prevent it. But. Okay, so we have the constructor. We have something to add the element. And what does the add the element do? Where does it add the element? Yep, to the beginning of the list. So later when we go across the list, what order will those elements be in? Reverse order, right? So if we do add element 1, 2, 3, 4, 5, and later we go to print it, and we go in order, it will print out 5, 4, 3, 2, 1. Because what we're doing is each time we take an element, we add it to the front of the list. Okay? By the way, I sort of thought of another analogy for linked lists. Do you all eat at the dining hall at Leo's? I love Leo's. So, I mean, I only go there like once every 5 years. But anyway, I don't have to eat there all the time. So when I was an undergraduate, when we went to eat, they had these rolling carts that had plates, and they were all stacked up on a spring. Do you have those still? Like when you get a plate, where do you get a plate from? It's just a stack of plates. It used to be they had this rolling cart, and it was like a spring-loaded thing. When you put plates on, the weight of the plates would push it down, so that when you took a plate off the top, the next one would pop up. Anybody seen that? Like a cup dispenser, sort of. Yeah, you pull the top. So a linked list is kind of like a cup dispenser too, right? Because when you put things on, you're pushing it down, and you can only get at the top one from the head. So if you want to get to the 5th plate, you have to pull off the first 4 plates. No? All right, well, a Pez dispenser. I don't know if I can support that, but yes, maybe like a vending machine. Yeah, like things have to go in the front. Someday I'll find a good analogy for this. So, okay. So here's our add element. Essentially what we're doing is we are working with a temporary thing. We create a new node. We set the data. We set the next node in the temporary thing to point at the head of the list, and the head of this to point at the new node. So that's how we push things onto the list one thing at a time. Okay? You should be able to recognize this code because we're going to be doing a lot of this. The other thing we talked about last time was how to go across the list and print everything that was in there. Okay? And what we see is that we have a loop that looks exactly like this, and we're going to use this for everything. Okay? What you do is you take a temporary node and you set it equal to the head. Okay? You take a temporary node and set it equal to the head. Then what you can do is you say, while this node is not null, you can do some operation on that node, because now you have a pointer to it. That temporary pointer is pointing at the node. So in this case, what we're choosing to do is output the data. All right, everybody see that? Like you have this loop, then you have some operations that you're doing. In this case, we're just choosing to print the thing. What other operations could we do right here? We could do get whatever, we could do set whatever. What else? Anything your heart desired. You can have an if statement to see if it's something like, and you can see that. And then we advance the pointer. This temp equals temp get next node means the temporary node switches from pointing at the node to the thing that is inside that node points at next. So it's like switching from the first thing to the next one down. We call that advancing the pointer. Okay, that's like our 2-minute overview of what you missed to go home early for Thanksgiving. Let me tell you, you look happy to be back today. So, all right. So let's look at other examples of how to use this particular loop. And one of the things that we're going to need to be able to do for the project is find a particular subject by ID. Okay? So let's look at a method, a prototype that will allow us to find an element. So how are we going to find the element? What is the basis for finding our element in this example? What are we going to look for? Yeah? We're in the project it will be find subject by subject ID. But you would find it by int. You would have some int. And what is this thing going to return? Like once we've found it, how do we tell where it is? Yeah? What's that? Mamadou, go ahead, sorry. And so how do we define a pointer in this case? It's a star. It's going to be a pointer to something and a pointer to what? Because we have to actually tell it what it's a node. Absolutely. So here's our find thing. And what we're saying is we're going to find an element. We're going to do it by integer. That is, we're going to look for a particular value. And the thing we're going to get back is going to be a pointer to that element. Okay? What is the name of the element that we find going to be? Yeah. It doesn't have a name, right? When we're dealing with these nodes, when we're dealing with these subjects, they do not have a name. So we can refer to them by what data they have inside. We can, if it's unique, right? If it's not unique, you have a problem. But we can find them by what data is inside or by their address. And their address will generally be unique. Okay. All right, I've been talking for 22 minutes. You all need an early break today. Everybody stand up, stretch, scream, have a drink of water. You don't want to stand up? You don't like standing up? Oh, okay. Sure. Would the box have that we drew, would that have two? It would have three things. It would have, it would have the int, the double, and then the pointer in it. So if we're going to draw like a subject one, it would have an unsigned ID, a character, and a pointer. So that's, yeah, that's a good question. Uh-huh. All right, welcome back. Welcome back from your mini post-Thanksgiving vacation. No more flirting, thank you. All right, so we were talking about having a class in the linked list, a method that returns a pointer to a particular node that we find by looking at its integer and what its data is. And we're just going to call this x because, we call this thing the toFind. We're looking to find this integer. Okay. How do we traverse across the linked list and see if any element has this data, the thing to find inside? Create a temp, why? All right, this step of creating a temporary node that equals the head is incredibly important. And if you were here last time or looked at the video, one of the most common mistakes people make when working with linked lists is to omit this step and just start working with the head pointer. And what ends up happening is if you move the head pointer around, then you are no longer actually pointing at the list. You have lost the list. It is gone. That's bad. Okay? All right, so we have to make this. Then what do? How do we traverse the list? Yep. What kind of while loop? Yep. We're going to see this over and over and over again. This is, this is the new for loop. Just like we have for int I equals 0, I less than vector dot size. This is the exact same thing we're going to do. Okay, so while we're looping, what do? Okay, an if statement. And what if statement is it? If what? If the thing we're trying to find, this integer, we have a temporary pointer to an element, how do we compare whether that element has the correct data in it or not? Yep, we just do this. Temp, arrow. Anybody not know the arrow operator? arrow operator? Come on, I know some of you don't because you didn't watch the video last time. Okay, the arrow operator is the same as this. Arrow is the same as doing that. So you can, or that and a dot. So we can do type get data. I hope that's what we named it before. And this will say, get the temp pointer, follow it to the object that's there at the end of it, and when we get there, call the get data method on it. Okay, just make sure get data is what we used, yep. So call the get data method on it. So this will take a pointer, temp, dereference it, and when you reach the object, call the get data method on it. And now that you have the data, what can you do with it? Compare it. How do we compare? There we go. What if we found what we were looking for? What do we return? Temp, absolutely, because temp, we're treating it like a pointer, right? In our mind, it's a little arrow. In practice, it's just a box with an address in it. So we can just return the address and say, hey, here's the address of the thing that you were looking for. Okay? Are we good? All right, so that's what we do if we find it. What happens if we don't find it? Yeah? We advance the pointer. How do you advance the pointer? That's it. All right. Anything else we need to do here? What happens if we reach the end of this code down here? We've looked at each thing in the data. We've never returned because we never found what we were looking for. And then all of a sudden, temp is null. What do we do at that point? We have to return what? So we have to, at this point, if we get down to here, if we reach this part right here, we haven't found what we're looking for. It's just, we haven't found it, right? It's possible that we're looking for something that is not on the list. So we have to return something because the compiler makes us return. What can we return that indicates that something is not on the list? Return null, yeah. All right, everybody kind of with me on this? Who's with me? Who's against me? Who thinks you'll be really good at this after the project? We're going to try and get there before then. Okay, pointer's important, so we're going to do some practice on this. All right, everybody understand what's happening here? Any questions about this? Yeah? I don't understand what, that code were to return null. I don't understand what that would mean. If this code were to return null? Oh, well, we're going to run some examples of this. Why don't we look and see? Does that work? So we've written the method. Let's actually check it and make sure it works. So one thing we haven't done is compile this and make sure it works. So tension was getting me there. Okay. And if we go and look at what's going on down here, we have a whole bunch of things. We print the list, right? Now what maybe we want to do is what? Find an element. So let's do this, cout, and we can just do find element. And which one do you want to find? 15? Okay. So we're going to look for this element 15. Is 15 actually on our list? It's not, right? Because we added 666, 549, 7, 0, and 2 minus 8, which is minus 6, right? When we print this list, what order do these print out in? Backwards, so it's minus 607, 549, and 666 is what we'll see. And then if we cout find element 15, what is this going to print out? It's going to print out this thing. Find element returns what? What is null? What type is null? A pointer, which means it is an address. So this find element thing returns an address. What does an address look like when we print it? A bunch of hexadecimals. What will a null address look like when we print it? It'll look like a 0. And in fact, I think it's just going to print out 0. I don't think it's going to show us all the hex. Oops. Yeah, sorry. Okay, list.element. Is that better? Because we can't just find element without telling what object to run it on, so. All right, so let's run it and see what happens. This is pretty exciting. Yep. So here's what it prints out. It prints out the list in backwards order, which is what we expected, right? And then it prints out the address that it found, which was null, right? It just didn't print it out with 20 zeros in a row. So that's what it looks like. What does it look like when we print out something that we know is there? Which one do you want to find? 7, okay. What is this going to print out? The address. You know what, I'm going to make one change to our print list thing. I don't like it when it prints them vertically. I'm going to make it so it prints them horizontally. That'll be a little bit neater, okay? So all I did is I removed the end line and then put 1 at the end, so everything will print on a single line. So, and now we're going to go and we're going to add the elements, print the list. It will appear on one line together. We'll find the element 15 and then 7, okay? Anyone want to make a prediction on where node containing 7 is going to be? Yeah, I pushed enter way too fast. So yes, so here's what we see. We print the list. It comes out in inverse order. One of these things returned null. The next one returned a particular address, 0x7fd467d024f0. Do we ever care about that address? Not really, right? We're printing it out here, but that's not really what we want to do. So what might be nicer is if we did this. This whole thing turns into a pointer. This dereferences the pointer and calls that. Okay. Is that horrible, scary notation? Yes, it is. Let's see what happens, though, when we run it. 7, which was the element we're looking for. So what this says is list find element 7. Find element 7 gives us what? What does this thing return? An address. What does the arrow operator do? It says go to that address, and when you get there, run the getData method. All right, everybody with me on that? So that's how find element works. You'll need something like that in your project. Yep. No, we're going to do that next. I'm going to do that next. Okay. Okay, anybody good on this? Let me ask you a question. What happens if we, any other questions before we go on though? Everybody good? All right. What happens if we print the data of this thing up here? Yep. Okay, we have a guess that'll return 0. Yes, sir. There's a guess that we don't know it'll return? Yep. Some sort of null reference. Let's try it and see what happens, okay? We know this thing right here. What is this going to return? Null. It's going to return a 0 address because that's the way we set it up and because this thing isn't in there. And so we're going to get the data from that. Compile as well, so everything must be fine. And when we run it, segmentation fault. Segmentation fault. When you try to dereference a node that doesn't exist, you will get a segmentation fault. Segmentation fault is what the compiler tells you when you try to access a pointer that points outside reasonable memory space, the things that may not exist. Okay? It will crash and die. You will see this while you are working on your project. Okay? If you don't see this while you're working on the project, I have not made the project hard enough because you should experience this. Right? When you see a segmentation fault, how do you figure out what is going on in your code? Okay, so there's a lot of pointers in your code, right? There are going to be a lot of pointers in your code. And when you get a segmentation fault, it can be very difficult to figure out which one is going bad, like what's going on where. So here's what I recommend you do. I'm only telling you this because I like you, right? So what I recommend is doing this. Put a whole bunch of debug output statements. I can't type today. So what I'm doing is I'm adding a whole bunch of output statements to this that when the program runs will let me know what has happened and where my program has gotten to, okay? Because what you're going to see is when we run this, if it compiles, is it going to compile or did I make a mistake? I think we mentioned that, but what you can see is that it says adding element, done adding elements, about to print, done print, about to do first find, segmentation fault. Okay. And that way, it'll let you have an idea where things are crashing. So we can look back at our code and say, oh, it's done with the print, about to do first find, done print, about to first find. Then it crashes, and we never see the second find. So now we know that the line that's causing it to crash is this. Okay. Now the question is, what is C error? C error is like C out, except for error messages instead of regular output. The way I'm using it in this program is just to differentiate it from C out statements that we want, so that later, when you want to take out all these debugging statements, you can just look for the C errors and you don't have to look at every single C out to see if it's a debugging statement or not. Okay, that's the way I'm using this. So, everybody see this? So here's your rule. When you start getting segmentation faults, you can do this, and this will help you figure out where your segmentation fault is. You may have to put a whole bunch inside your methods too, like the method saying, you know, about to run the loop, print out all the elements, things like that. So you can use output to do that. Okay. Everybody on board with that? Seriously, this is really helpful. If I didn't tell you this, you'd be unhappy. Yep. It might. On Xcode, it might show you where segmentation faults occur. Yes. I'm going to show you one other way to do this. This is the easy way, and there's another more powerful way. Anybody want to see the more powerful way? Yeah. All right, so here's what we're going to do. I'm going to do the normal compilation, G++, but I'm going to add this thing in there right there. What is that? A -G. -G. Add a -G when you compile. You will not notice any difference in what's going on. The compile will happen exactly the same. What the G is doing, though, is generating some additional debug information that you can use in a program called GDB. And then you just say GDB, which is GNU Debugger. This is a debugging program that helps you debug things. It is incredibly powerful. I'm going to show you only the very most simplest thing you can possibly do with it. So, except I don't have GDB installed on here. Wait, hang on a second. Hold on a sec. Okay, let's do it on CS class. Let's make sure GDB is here. Good, it's working. All right, so I do the same thing here, G++, -G, node3.cc-o node3. Thank you. All right, and now I type GDB node3, and it will say all this stuff, blah, blah, blah. Here's the important thing, reading symbols from node 3, and then we just type run. And look, it says program receives segmentation fault in node get data at node 3 cc23 return data. Okay, and so if we just say where, it will actually tell you where it crashed. It crashed in get data And the reason it crashed at dig data, see this? It says this equals 0x0. That was null. So this isn't the best example, but in other cases, you can use this to figure out where things are crashing. Okay. It's a 5-minute demo. So when you get into trouble and things are crashing, put in output statements and try and run it in GDB. Compile it with the -g flag, run it in GDB, and GDB will tell you where it's crashing. Everybody sort of good with that? And if you're using Xcode or something like that, it'll probably tell you too. Any questions? All right, guess not. You all are quiet today. All right, so here we are. Right place, okay. All right, so let's get rid of this because this doesn't do us any good. It just causes crashes. All right, everybody good so far? Do you want a little break? Yeah, stand up for 1 minute. I should have brought you all coffee today or something. Really, stand up, you'll feel better. Yeah, go ahead. Yeah, go ahead. That's really for backup. I'm not even really checking that. It's just in case the autograder does. All right, welcome back. So we had a question earlier about how we add things to the end of the list instead of the head, right? So kind of like pushback does. If we want to add things to the end of the list, what do we need to be able to find? The end of the list, right? If we can find the end of the list, we can easily add things there. So how do we find the end of the list? Yeah? Find a null pointer. Which null pointer is it we need to find? We find a null pointer. Which null pointer do we need to find? Yeah? If head is the head of the list, but if head is null, then the list is empty. There is no list. Yeah? So what we need to do is we need to find, the way we know we're at the end of the list is because we find a node, and the pointer in that node points to null, right? The very last node on the list we know is the last one because its next node pointer is null. Okay? So here's what we're going to do. Let's write a thing to find last, and this will find the last thing on the list. We're going to write a method that will let us find the last thing on the list. Okay? What parameter do we need if we're going to be looking for the last thing on the list? Do we need any additional information? Is it going to change from time to time? Like find element changes from time to time because we're looking for different things. Does find last change from time to time, or is it always the same? It's always the same. So do we need any parameters? Nope. Everybody understand that? The last node will always be identifiable because it will have a null pointer at the end. So we can just do find last node star is what we're going to get, and we'll do find last. Okay? Everybody with me? Who's against me? Is it really hard coming back for vacation, or just Pointer is just insane, or a combination of both? Both? Okay. Sorry to subject you this on right back from vacation. So we're going to get a pointer to a node, find last. We don't need any parameters. This is all part of the linked list class. I feel pretty good. So hope that helps. All right, how do we traverse the list looking for things? A while loop? Uh-huh. Okay. Why can't we just do this? All right, I'm trying to trick you. This is bad. This is really bad. You never want to do this with the head of the list, okay? I'm seeing how awake you are. You always want to do this, node star temp equals head. Okay, if you do just head, you lose the whole list. So while temp not equal to null, how do we know if we have found the end of the list? If what? Okay, here's the deal. If we wait until temp is null, I'm going to have to draw a picture of this really fast. Sorry. So here's our head pointer, and it points at one thing that points here, which points at one thing which points here. And this thing is null. So here's our list. Here's our head pointer. Here's our first node that points to the second node that points to the third node that is null. If we wait, if we have temp pointer here, and then here, and then here, and then we make temp null, it doesn't do us any good because temp is no longer pointing at the last element on the list. Does that make sense? So if we just loop through until temp is null, we have gone past the thing that we need. Okay? So how do we know which one of these things is the last node on the list? Yeah? Exactly. If we say get next node, and this thing is equal to null. And what we're saying is if we have temp pointing in an element, and we call the get next node, which tells us the address in here, and that happens to be null, then we know we're at the end of the list, right? Does that make sense? Really, you all look so miserable today. It's unnerving to be up here. I feel like the zombie outbreak's about to start. Okay. All right, so if the next node is equal to null, everybody understanding this, please? Everybody close their eyes for a sec. Close your eyes. Close your eyes. Raise your hand if you are baffled or confused. A few of you, okay. All right, we're going to try and clear that up too. So let's just do this fast, and I'm going to give you some practice on that, all right? And we can see. All right, so what we're saying is if we get down to here, if temp is pointing at a node, right, because temp will always point at a node, and if the get next node is actually null, meaning this thing isn't pointing anything else, we're at the end of the list. What do we do when we're at the end of the list? All right, eventually we're going to create a new node, but right now all we're doing is returning a pointer to the last thing. Okay? We are not yet adding things. So we return what? Just return address in the temp. That's it. If it's not there, what do we do? We're missing one thing before we return null. We have to advance the pointer. So we have to go on to the next one. And then, and only then, if we haven't found anything, return. So we have a method now that will traverse the list in the same way that we traverse the list every single time. Only this time it will stop if it reaches the last node on the list. Yep. The TAs are wrong if they told you that. In fact, I would say don't do it that way. It's a lot neater to have something that returns than it is to have multiple nested if-then else's. I used to believe that, and then I read code, and now I believe strongly in this. So it's okay to return early. Yeah. Yes? Yes, temp holds an address. Okay, and so originally what we're saying in here is we set temp equal to head, so it has the same address as head. And then if this isn't what we're looking for, we set temp to the address that's inside the bottom of this element, which happens to be the address of this thing over here. And then it happens to be the next one and the next one. Okay. All right, so this will let us find the last element. So let's actually see if we are finding the last element correctly. So if we find the last element, do you want to print out the address, or would you rather print out the data that's inside there? The data? Okay. So here's what we're saying, is we're saying on the list thing, call the find last method. The find last method gives us what? It gives us what? An address. And then given that address, we dereference it and call the get data method. And then we should see there. So what is this last element going to be, by the way? 666, because we put everything in reverse order. So let's see. Let's make sure that works correctly. We'll run it and see. Sorry. Okay, so we're able to find the element 7, and we're able to find the last element, which is 666. So everything is working beautifully, right? Yes, okay. All right, questions. Seriously, questions about anything. Even if I've totally lost you, where did I lose you? Yeah, go back to the code. All right, I'm going to change this up. Okay, so this is all the code we're going to show for the time being. Let's do something else. Okay? What I'm going to give you is I'm going to give you a handout that has a pointer exercise in it. I would like you to team up in partners, and to each of you, well, I'll tell you in a second, okay? You can even just close your computers up. You're not going to need them. You can look at Facebook when you're done. It'll still be there. I'm sorry, Instagram. Snapchat? LinkedIn? Here, got some more there. I have a lot of these, so. All right, so partner exercise, pair up with someone, and here's what we're going to do. If you look at this code says it has different points indicated in it. If you look through, there's point A, point B, point C, point D, point E, and point F. I want you to step through the code. Anybody missing them? I would like you to step through the code with your partner. Each of you take turns drawing what's coming out at a particular point. Here you go. Once more. All right? I'm going to give you like 10 minutes for this. So take your time, do it right. Everybody make sure that your diagrams are kind of like what I've been trying to draw on the board. All right? All right. So I'm out of candy, so I can't actually reward you with sugar calories for this. But let's go through this and take a look. All right. My hope is that if we're able to diagram this, you will understand it better. Anybody interested in where I got this problem from? This was on the final exam of the last time I taught this class. Do you think you are likely to see a problem like this on the final exam of this class? You are wise people. Yes. You will absolutely see something like this. Okay, so where do we start? Int main. So what's the first thing that happens after int main? Okay, what does node star temp mean? We have an address, okay? Node star means temp is going to be the address of a node, okay? So we're saying that we're going to have the address of a node stored in temp, but right now it is null. Then we say we're going to have the address of a node stored in a variable named head, and it is also what? How do we draw that? How about like that? Does that look good? So what we're using is, because we don't know what the addresses are actually going to be, except for null, right? We're just using arrows to indicate them. So this kind of arrow with a little grounded symbol to me is null. That means we have a pointer, but it is not pointing anything, and we know that it is not pointing anything. Okay. So we go on then and we reach the next loop. What does that loop do? What does for an I equals 0, I less than 20, I plus equal 5 produce? What values? What is the first value it produces? What is the second value it produces? Third? Fourth? Fifth? There isn't, right? So it produces 0, 5, 10, 15. So it produces 4 values. What does the code inside that loop do? It does. The first thing is it creates a node. Then it says temp set next head. What does that do? So in the portion of the node that stores an address, it copies the address and head to that node. So that node is now pointing at whatever head was pointing at, and then it moves head to point at the new node. This is code that does what? Adds objects to the beginning of the list. You should be able to recognize this. This adds objects to the beginning of the list. Okay? So if this is code that's adding objects to the beginning of the list, and we know that it's producing values for 0, 5, 10, 15, what's happening? So it's going to be boxes of 15, 10, 5, and 0, like that, right? And it's important to note that temp and head end up pointing at the same thing. Okay. All right, some of you are looking happy. Does that mean you got this part right? You psyched? Yes? All right, so we proceed on in the code. Now, we just printed out point B. Now we get to point C, the temp equals head, while temp does not equal null, C out temp get data, temp equal temp get next, C out inline. What does that do? What does that loop do? It prints out the data in what order? 15, 10, 5, and 0. Okay? This loop is exactly like we keep seeing, right? When we say temp equals head, while temp not equals null, C out temp get data, that's where you have the opportunity to access and do something with the thing you found. Temp equals temp get next, that advances the pointer. So what's really happening is temp is starting right where it is, temp equals head, and initially, like the first iteration of the loop, what's happening is temp points at 15, it prints out 15, it then advances the pointer to the element that has 10 in it, prints that out, advances the pointer to the element that has 5 in it, prints that out, advances the pointer to the element that has 0 in it, prints that out, and then what happens? Does it stop? It's cout's an end line, but what actually happens is then temp actually becomes null because it advances to the pointer in here as well, so temp should be null. Let me put this back the way it should be. Whoops. And hope I didn't make a huge mistake. I made a mistake on my thing. Okay, nope. What happens at point C, and I have an error on my thing, is I drew it like this, and I drew it wrong the way you're telling me to do it. It actually looks like this. I'm sorry, I have to unlock that. What ends up happening is temp actually becomes null. Because the while loop is saying while temp does not equal null, go on to the next thing. So temp is initially pointing at head, then it copies this pointer that points it at 10, then it copies the one that points it at 5, then it copies the one that points it at 0, then it copies the one that points it at null. Okay? So at point C, After that loop, temp is null, like that. Yeah? Nope. It doesn't. If you look at the thing, it says temp equals head while temp does not equal null. Right? The loop itself says does not equal null. So what will happen is it will keep looping until temp is null. And temp will only get to be null after it's assumed each one of these values, right? So first it goes, okay, I'm pointing at 15. I print out 15. Now I set temp to point at the thing this first node is pointing at. What is the first thing the first node is pointing at? Temp is pointing at the node that has 15, but inside the node that has 15, there's a pointer that points at something else. What does that one point at? So when we advance the pointer, temp changes from pointing at head to pointing at the same thing that the pointer inside has. So it moves on to 10. Right? It then prints 10. It moves on to the thing 10 points at, which is 5. It does 5. It moves on to the thing that 5 points at, which is 0. It prints 0. Then it moves on to the thing that 0 points at, which is null. So temp ends up being null. Okay? Everybody go on that? All right, so that's what's happening at point C. Now the first thing that happens after point C is that temp points back at head, and then we do some loops again. And when we say while temp get next does not equal null, temp moves on to temp get next. So let's look at what happens in that case, okay? So let's say that we have temp, and get rid of this really fast. So let's say we have temp, and temp is pointing at head, okay? So now we just executed the temp equals head directly underneath point C. Everybody with me? You see where it says point C and it says temp equals head? Is temp now equaling to head? Yes, because it's pointing at the same thing. Now we say, well, temp get next does not equal null. Does temp get next equal null? No, so we move on to the next thing. Sorry, my drawing program's a little weird here. We move on to the next thing. Is temp get next there null? So we advance the pointer to there. Does temp get next equal null? So we advance the pointer again. Does temp get next equal null? So we stop. So right there, we have stopped. Okay. All right. So then we end up at point D. And if we unveil point D, you will see that temp is now pointing over there. Everybody with me? Okay. From point D, we said head equals head set next temp. Head arrow set next temp. What does that do? Yep. Yep, we go to the box that head is pointing to, and then, yes, we change the pointer in the box that head is pointing to that happens to have 15, and we make that point at what temp is pointing at, like this. So now that points over there. Okay. Why do we do this? Because we're professors on an exam and we have to be a big jerk and make sure that you understand what's going on. So what happened to the nodes 10 and 5 right there in the middle? Can we ever get back to them? We cannot. They are lost. We no longer have a pointer to them. They are a memory leak. Okay? And then finally we say temp equals head. While temp does not equal null, we output data. This is just printing the list again. And then actually point E ends up looking exactly like point F, because what happens is temp goes back, it prints 15, it prints 0, and then we're done. Okay. All right. So you're going to need to be able to diagram things like this. Really, it's the only way you can understand this stuff. All right. Have a good Tuesday. Oh, by the way, I have printed out answers for all these too. You're welcome to one, so you don't have to copy it. Just bear in mind, and point C, there's an error. Instead of pointing it at 0, it should point at no. And I'll just put these on the front. You can grab one on your way out. So, have a good Tuesday. You can always ask me a quick question.